the oceans there, you've got the mid-Atlantic ridge coming up from the magma below the surface that's created those mountains under the sea. Believe it or not, the idea was originally proposed in 1859 by Anton Snyder, who was a creationist. But his ideas weren't accepted at the time, and it was only resurrected much, much later. Perhaps got overshadowed by the other person in 1859. So in the conventional plate tectonics, you've got slow movements of plates. Here's a picture of the plates at the continental edges being subducted down into the mantle of the Earth. And then the creationist theory speeds up this process and makes it a catastrophic process associated with Noah's flood. I've borrowed different slides from different people, which is why all the sort of formatting looks very different. This is just a schematic of the sort of configuration before the flood. You've got continental crust, which is lower density, so it sits higher on the mantle, and the oceanic crust is high density. So it's higher density than the mantle, which is it's not really liquid, but it's deformable. And when you think about it, that's an unstable situation. You've got something more dense on something less dense. So if you get that continental crust breaking up, or sort of the oceanic crust breaking, then it's going to start sinking into the mantle. And that is what is proposed in the catastrophic plate tectonics. At the time of the flood, the seafloor is more dense than the mantle, which is why it sits low down. It starts to subduct into the mantle. As it does so, it releases energy, which heats up the mantle. And as the mantle gets heated up, it gets more runny. It's like sort of treacle being heated. It gets more runny, so it's easier for the plates to flow into it, so it speeds up, which releases more energy, which heats it up more, which means it gets into a sort of runaway process that gets faster and faster. And in this modelling, the plates are moving at sort of meters per second speeds. And while all that's happening, in the middle of the ocean, where the plates are separating, you're getting new seafloor being made as the mantle from underneath comes up in contact with the water. And that rock is initially hot, which means it's less dense, so it sits higher on the mantle. Okay, it's not sinking, so it's sitting higher up, which means it's displacing the water above it higher up, which means that water is beginning to cover the land. So this is actually a mechanism by which water can inundate the earth. Okay, it's not about lots of rain and rivers overflowing. It's about a massive catastrophic process where this new seafloor is rising up and pushing the water onto the land. You're also getting sediment deposited onto the land. That's why we find lots of marine fossils on land. And once all the old seafloor has been subducted, you've got the hot new seafloor is then sitting happily there, and it's stable because it's less dense, so the process comes to a halt. But as that new seafloor starts to cool, it becomes more dense, so it starts sinking down. So as it starts sinking down, the sea levels start dropping, the water starts draining off the continents. That's where the water goes after the flood. There's a mechanism for the inundation of the world here. You've also got a way of creating intense global rain, because you're going to get steam jets where this new seafloor is being created. So that's another way that you're getting more precipitation. It's a lot more complicated than that, but that's the sort of essence of what's going on. This explains the global scale of geological sediments. It explains the formation of mountain ranges in recent geological history. It also explains these observations here, where putting sound waves through the Earth, you can map the rock that is found within the Earth's mantle. And what's been discovered is there's areas where there is this sort of low temperature rock that's been subducted into the mantle. And this is a real problem for the conventional theory, because on The conventional timescales, all of the stuff that's been subducted should have melted, okay, in the time that it's been there. But yet we can still see these plates sinking very deep into the mantle, which would fit exactly with this happening actually as a very recent event. So there's some direct evidence that would support this sort of a model. Another thing that's going on during this process is that you're getting magnetic field reversals. In the conventional, this is one of the great evidences for the conventional plate tectonics, that as the mid-ocean ridges are formed, you've got the magma coming up, it's being cooled. Within the rocks that are formed there, you will freeze the magnetization direction of the Earth at that point. And over time, the direction of magnetization in the Earth changes. So then the next bit of rock to form will show the opposite magnetization. And you'll sort of get this sort of conveyor belt of sort of magnetization going in different directions as this new seafloor is created. Well, in the creationist model, the same thing happens, but it happens on short timescales. And the way these plates subduct actually gives you a mechanism for giving you magnetic field reversals, which is a problem with the conventional theory. And so the creationists that developed this, Russ Humphreys, predicted that you would be able to look at lava flows on the land that were occurring at the same time as this process, lava flows that would solidify in a matter of days, and you should be able to see different directions of magnetization in these lava flows. And sometime later, that's exactly what some scientists found. Interesting, a creationist prediction. Do you associate science with being able to make predictions that can then be tested and verified? Well, creationists have done that. He also made some predictions about the strength of planetary magnetic fields that were also confirmed. So there's other evidence that's supporting this. After the flood, there's a lot of other catastrophism going on. An ice age naturally flows on from this model. Bizarrely, you need a hot ocean, or a hot ocean will create an ice age. The reason for this is that you get increased evaporation and more precipitation at high latitudes, which will then come down as snow. And if you've got lots of cloud cover, lots of precipitation, you're going to get cold summers, especially if there's lots of volcanism as well at the same time, blocking out the sun. And that's what creates an ice age, when the ice doesn't melt again in the summer. And after the flood, the sea is very hot because of all these processes that have been going on, and an ice age naturally flows from this. And this has been modelled by, again, someone with expertise in this area. This is a slide I've nicked from Kurt Wise. Don't even try and read it. All he's trying to set out here is, in the green, the data that is explained both by conventional plate tectonics and his catastrophic plate tectonics. The red is data that's explained better by catastrophic plate tectonics. And then the blue is just other phenomena that are also explained by the catastrophic plate tectonics. So we're arguing this is a model that can explain a lot of things, and explain some things better than the conventional model. It's not just geology. There's baraminology. We've created a new term here. Okay, baramin. This is created kind from the Hebrew. Trying to understand what were the original created kinds, and then understand how they diversified to create the variety of life that we find today. So you're thinking about biological change. Creationists are very interested in biological change. But I don't understand baraminology, okay? And I'm not a biologist, and you'll have to look into the literature yourself, and I'm quite relieved I don't understand it, because that probably means that it's something fairly technical, something fairly expert. This is a sign of maturity in creationist thinking. Let me just say something briefly about the geological column. We are standing on miles of rock. Well, how do we explain it? It's one thing to complain about the evolutionary interpretation, which sees, development of creatures over a very long time scale. How do we understand it? Well, there's different understandings amongst creationists, but one that I'm showing here is that Precambrian rocks are sediments before the flood. The flood sediments are these primary and secondary rocks. And then there's actually a lot of post-flood sediments, the tertiary and quaternary rocks. And how are we trying to explain the fossil sequence here? Well, in the flood rocks, this is a model that's very much under development. But we want to argue that the flood sediments reflect the inundation of a highly ecologically zoned pre-flood world. It was a very different sort of world to what we know today. There was probably massive floating forests across this world. And, as I say, a very strong ecological zonation, and that is what is reflected within the geological column. Post-flood, we are actually looking at the development of creatures over time, as they're spreading out over the world and developing into new environments. So we're almost looking at evolutionary sequences in those rocks. Things like the horse, the sequence of horses, is something that creationists would accept. It's showing a development in these creatures over time. And you can even start studying some of these fossil lineages in the post-flood world, for example, to identify created kinds on the Ark. There's a recent paper by Kurt Wise on this in a conference just a couple of weeks ago. One person here was at it anyway, along with me. And this is research work that is going on. But there's a problem. Doesn't radiometric dating invalidate the whole thing? This is what Stephen Gould said to Kurt Wise when he tried to present a sort of primitive creation model to him. He said, yeah, that's great, but it can't be right because of the radiometric dating. So how do we tackle these questions? For the sake of time, I'm going to assume you understand broadly what radiometric dating is. We're looking at the level of isotopes in rocks to infer ages. The popcorn there is supposed to be a sort of very daft analogy for it. I'm sorry if that's a bit patronising for this audience. But to cut a long story short, the creationist hypothesis is that a lot of decay has genuinely occurred. There's no question about that. We see evidence of that. But there were points in the past, possibly in the creation week and possibly at the flood, at which decay rates were faster. And if you're like me, if you hear that, alarm bells start to ring and you think, hang on a minute, this sounds like invoking miracles to get things to fit. You've got a real problem with the data, so you're sort of saying, well, let's have a miracle and sort it out that way. Well, we need to be careful of that. Although realise that in conventional science, I mentioned the inflation theory in the Big Bang model. Well, in effect, that's a period where you have a very rapid change in the expansion of the universe in order to get the data to fit. And that's something that's accepted in that context. Perhaps we should be open to ideas in other areas too. So, but nevertheless, we should perhaps be sceptical. So the real question is, well, it's fine to propose that, but is there any evidence for that? Is there any basis with which to say that these rates have been changed? Well, there's some indirect evidence from things like this. There's actually a lot of evidence within conventional geology that would make you question radiometric dates. For example, these two rock formations here in the Grand Canyon. There's a 10 million year gap between these two sets of rocks, the way they're dated. But where's the 10 million years of erosion between these two layers? If you've got Hermit Shale sitting there for 10 million years before the Coconino sandstone lands on top of it, well, surely there's going to be some erosion, surely there's going to be some processes going on. Why is it such a straight boundary? Does that time really exist? And there's other things that you could point to that would make you question, at least, whether the radiometric data is really giving you proper dates. And then there's these mysterious things called radio halos. Now, polonium has got a bit better known because it was the element that was used to poison the Russian intelligence officer Alexander Litvinenko in 2006. Now, we're not interested in its poisoning qualities, but in the damage tracks that it can leave in rocks. When atoms decay, radiometrically decay, they leave these sort of rings where the particles that they emit finish up in the material, and they leave this damage there. And the size of the rings depends on the element, and you can identify what element it is from that. And the problem with these polonium halos is that they have very short half-lives. Okay, they're very short-lived, so they have to form very rapidly. But you can only get the polonium from the decay of uranium, and you sometimes find these polonium halos slightly separated from the uranium that they've been derived from. But to get a polonium halo, you need a lot of polonium to be formed. And to get a lot of polonium formed, you're going to need a lot of uranium to decay. But uranium decays very slowly in the conventional understanding of its half-life. And it becomes a real problem to explain how you can have these polonium halos formed. And an expert in dating called Brent Dalrymple called this creation's tiny mystery when some of this evidence was presented at one of these sort of creation trials in the 1980s. And it's still something of a mystery. Well, there's creationist models to explain this, and it fits with this idea that decay rates were accelerated in the past. And in this field of radio halos, it's creationists that are doing the work, because other people aren't interested in this. It's just an anomaly that's a bit embarrassing. But for creationists, it's something very interesting. So they're doing new work. They're discovering new things about radio halos. Okay, science is being enriched. This work wouldn't be done otherwise. But the creationists, because it's a question that interests them, they're asking new questions. They're doing the work here. Another area they've done new work is in carbon-14 dating. Because carbon-14 has a relatively short half-life, much longer than polonium, but relatively short compared to things like uranium, there should be no carbon-14 present in geological samples. And yet it's a well-known fact that any sort of sample of coal or something analysed has levels of carbon-14 far above the detection limits. And creationists have sent carbon samples to labs to investigate this further. Something you wouldn't do as an evolutionist. There's no point, because it's old. It's not going to tell you anything interesting, whereas creationists think, well, no, this should be telling us something useful. And the evolutionists have to say, look, it's just an anomaly. There's contamination or something, even though it's been ruled out very meticulously that there is no contamination. It's an unexplained anomaly. For a creationist, it's useful data. And what has been discovered by some of the creationist workers, they have looked at the same rock samples and tried to analyse them by several different radiometric methods. Date the same rock by different methods. This is something that you wouldn't do as an evolutionist, because the method's reliable, so you're just going to date the rock by the easiest method to use, and that's going to give you your date. It's a waste of money, because it's an expensive process to do this, to go and measure it by lots of other methods as well. But creationists were doing this work and looking at how using different isotopes, it actually systematically gave you different ages. And this was the trend that was discovered, that the way the ages that came from these different methods, it actually corresponded to the type of radiation emitted and the half-life of the elements concerned. So the different dates that come out of this, an evolutionist would say, well, it's just anomalous. It's something that, something's gone wrong somewhere. The creationist says, no, this is interesting data. It's turning anomalies into useful data, which is the real heart of what it means to be a scientist. It's bringing coherence to data that would seem to be disparate. And what was discovered experimentally here actually fits some theoretical models of how the decay rate should change. in this speeded up process. There's another bit of evidence that supports this interpretation as well. One of the things that's produced when certain elements decay is helium. And the helium is left there in the rock, but over time that can diffuse out of the rock. And there was these zircon crystals that had very high amounts of helium. There had been an awful lot of decay occurring, that had produced all this helium, but there was an awful lot of it still left in the crystals. And if a long time scale, if these rocks were really, millions or billions of years old, that helium should have diffused away, or so it was thought. But the problem was no one had actually measured the diffusion rate of helium in these rocks. So the creationists said, well, look, here's a test for our theory. Let's actually measure these diffusion rates. So again, they sent the samples off to a lab that was expert in this and got them to measure diffusion rates of helium in these rocks. And when the results came back, it showed that on the conventional geological timescale, that helium should definitely have all come out of these crystals, whereas actually it was all still there. And the only way to fit that data was that these rocks were actually much younger than the radiometric dates would suggest. So it's another piece of evidence that's showing that the standard interpretation of those radiometric dates is wrong. Or at very least it's not consistent with other data that's equally, if you like, well established. And so the challenge for anyone is to explain all of this data. The great temptation is to sort of cherry pick the data that fits what you want it to say. Creationists can do that too sometimes. But we've got to explain the age estimates that come from all sorts of different methods. There's a book there by that guy I mentioned, Brent Dalrymple, The Age of the Earth, and he lists loads of different ways of dating the Earth. And there's a lot of methods that actually give younger ages than the radiometric dates. Things like the amount of salt in the sea, the amount of sediment in the sea, helium in the atmosphere, this sort of thing. So what do you do with that? Well, he just argues the radiometric dates are the most reliable. Those are the dates. The other things, well, they're just not very reliable methods. But I think as creationists, we in the end should be able to account for all of that data and explain it consistently within one set of dates. We haven't completed that at all yet, but I think we're actually going to be in a position to not cherry pick in the way that the evolutionists are doing. So let me just conclude with this summary. Isn't this interesting? Well, maybe you don't think so, I don't know. But I think this is interesting. This is real new science. There's people doing experiments, making predictions, building models, turning anomalies into useful data. It's doing something new. And there's method in this, okay? I think it's method that distinguishes the best research in any field. That you're not just cherry-picking data. You're taking into account artifacts. It's very important in the work I was doing in my research. People would look at pictures from microscopes and think you could just interpret them directly. You can't. There's lots of artifacts you need to account for. Different independent lines of evidence, consistency in approach, not being ad hoc. And those are all things that are demonstrated by the best creationist research. And I would say that even if some of these ideas are wrong, science is richer for this research having been done. No one else had measured those diffusion rates. No one else was investigating the radio halos in the same way. No one else was getting all those radiometric dates that the creationists were. We've enriched science through this work. And I want to be clear that none of these models I've talked about are demanded by the Bible. They are consistent with those biblical parameters I've given, but they're not demanded by it. Okay? There could be another model that actually explains the data better that is also consistent with the Bible. There's plenty of freedom to do scientific work. And there's plenty of questions. You would expect that. We've only just started the project, and if anything, we need a bit of help. We need highly qualified scientists in lots of disciplines to help us develop an alternative model of Earth history. That's a project that I think is enormously exciting, and it's something where we can do something genuinely original and new. And let's see where it takes us. Let's have the freedom to pursue this research. Whatever sort of definition of science you have, I think the sort of models I've discussed fit that sort of science. It's real scientific work that I think is very interesting and fruitful. And if you want a better feel an introduction of a broad creationist model, then do look at these books here. You can order them. Not that easy to get hold of. I've got my own copies here. You can't have those, but you can get them from Amazon. They're both really the same. It's the Something from Nothing is a sort of slightly simplified version of what's in Faith, Form and Time, but it gives an overview of a sort of complete creationist model. And there's some websites as well to follow different areas up. And I'm sorry I've gone over my time, but thank you for listening so patiently.